Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be talking about bond energies. So again, in this series of videos I'm talking about the energy of reactions, and in the previous video I talked about a way of calculating the standard enthalpy of a reaction by using heats of formation. So you can use the heats of formation to calculate the heat of a reaction. Another way that you can calculate the heat of the reaction is to use average bond energies. So the bond energy, what is it? So it's the energy that is needed to either break or form a bond. So it takes energy to break bonds, right? So to break a bond, remember it's an electrostatic force that's holding atoms together, and that's the lowest possible energy. So in order to bring them apart, you got to increase the potential energy between the atoms. You got to break them apart. That's going to require energy. And so that's an endothermic process. You got to put energy in. When bonds form, you got energies, you got atoms that are far apart. Atoms are not together. And so that's unstable. They want to be more stable. So they're going to come together, and that's going to lower their energy, and that's going to release energy when they're forming new bonds. So that's exothermic. So forming new bonds is exothermic. That's a release of energy. And breaking bonds requires energy, and that's endothermic. So if you know how much energy it takes to break a bond, and you know how much energy is released when you form new bonds, you can add that all up together and figure out what the heat of a reaction is based on the bonds that are changing during the reaction, right? So you can figure out what bonds are broken, what bonds are formed, and calculate the difference between the two. So what you need is a list of bond energies. And so bond energies are going to be given to you in a table. You don't need to memorize them. So you'll look up the bond energies of the various different bonds you have in your reactants and in your products, and then you calculate the difference. So these values that you look up are averages, because not all carbon-carbon bonds are the same. Not all hydrogen-carbon bonds are the same. So you got to take an average of them. So here's a little picture to kind of represent what's going on. So here, this would be like the combustion of methane. Here I have a methane molecule and two oxygen molecules. And so that's going to form, these are my reactants. And when I form products, I get two carbon dioxide and one water. And so, for example, so that's my those are my products. So what happens is when you're doing, if you're using bond energies, you just think to yourself, okay, what bonds do I have here? And let's break them all. So I'm going to atomize this whole thing. So I'm going to break all of these bonds, and I'm going to break these bonds here, and I'm going to create just atoms. So I calculate the amount of energy it takes to break all of these bonds, and I add them together. And that's the amount of energy it takes to put in to create just atoms, all separated atoms. And so this is going to be the endothermic process here. And then I form these atoms into new products. So I'm going to make new bonds, and then I calculate the amount of energy it takes to form these new bonds. And so I calculate the amount of energy here, and I calculate the amount of energy here, and then I add them up. And this side here is going to be negative, because when you're forming bonds, energy is released. So whatever values I get here, that's going to be negative values. And then here is going to be positive, because I have to put energy in to break the bonds. So when I add these together, I'm going to basically take the bonds that I'm breaking and subtract that from the bonds that I am making. So it ends up being bonds broken minus bonds formed. And so that becomes the delta H of the reaction. So basically I get the difference in the amount of energy in reactants versus amount of energy in products. And so you can see here that the energy of the products is lower than the energy of the reactants. So this would end up having a delta H that is negative. So more energy is released. Okay, so that is kind of a picture of what's going on when you use the bond energy method of calculating delta H of a reaction. So let's go over an example. Okay, so here we go. Here's an example. This is the equation I was referring to. So when you take that picture I had and you can translate it into this equation. So the heat of the reaction is going to be equal to the sum of the bonds broken minus the sum of the bonds formed. So you're subtracting the energy of the bonds formed because all of the energies you're going to look up in the table are positive. And so remember, when you're forming bonds, energy is released, so that's going to be a negative number. And so that's why we're subtracting the sum of the bonds formed. So you take your bond energies that are broken, and then you add those together, and then you take the bonds formed, add those together, and you subtract bonds formed from bonds broken, and you'll get the heat of the reaction. So here we have our reaction. We have the question is, what is the delta H of the reaction for this reaction here, where we have 2 moles of hydrogen reacting with a mole of oxygen to form 2 moles of water. So what we're going to do is we're going to break all the bonds in the reactants, and then we're going to form the bonds in our products. So notice that we have 2 hydrogen molecules. If I write it out, it's clear we have 2 hydrogen-hydrogen single bonds to break. And oxygen, we have 1 oxygen molecule, so we have 1 oxygen-oxygen double bond to break. And for water, when we break these atoms apart, then we got to reform the atoms together into 2 water molecules. And so that means we're going to put together and form 1, 2, 3, and 4 HO, a hydrogen oxygen single bond. So we have 1 hydrogen oxygen single bond, another hydrogen oxygen single bond, and then 2 more here. So that's a total of 4 hydrogen oxygen single bonds that we have to make. So if we take our table here, we see that, okay, so for the bond hydrogen single bond, it's going to be the bond energy, the average bond energy is 436 kilojoules per mole. Now this per mole here is per mole of bonds broken. So if I break one mole of hydrogen single bonds, that's going to require 436 kilojoules of energy. If I want to break 1 mole of oxygen double bonds, that's going to require 498 kilojoules of energy. So that's what the kilojoules per mole area, that's per mole of bonds broken. Okay, so here I can use the table of values and plug them into my equation. So it's bonds broken, the sum of the bonds broken. So I have to break 2 hydrogen single bonds. So that's 2 times 436 kilojoules, right? So 436 goes here. So that's the number of bonds, hydrogen single bonds that I have to break, plus 1 oxygen double bond. So 498 goes here. So 1 times 498 kilojoules. So all of that added together, this is my bonds broken. And then I'm going to subtract the bonds formed. So here I'm forming 4 hydrogen-oxygen single bonds. So I'm multiplying that by 4, and I have 4 times 463, which is the bond energy of my oxygen-hydrogen single bond. So when I do the calculation, I find that the number here, the delta H of the reaction, is a negative 482 kilojoules per mole. And so because this is negative, I know that it's exothermic, which means that the energy of the products is lower than the energy of the reactants. And what that's telling me is that the bonds in my products are stronger than the bonds in my reactants. It's easier to break the bonds in my reactants, and so they form stronger bonds in the products, and that's going to release more energy than was there before. Okay, so that is a good example of how you can use bond energies to calculate the delta H of a reaction. So I hope you enjoyed this video. If this was helpful in any way, then please, by all means, like the video, share the video, hit that like button, and also make sure that you subscribe to my channel. Hit that notification bell and also click all so you can be notified by all the videos I put out. And finally, put a comment down in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. Have a great day.